Ladies and gentlemen, if I could have you take your seats, we're about to begin. And this one's going to be a little bit more interactive, so prepare yourself. And otherwise, I would ask you, don't be on your phones, and because it's generally, that's why we hide them a little bit when we're sending our text messages. But right now, I'm going to ask that everybody brings out their phone, right? And we're going to give you a little bit of instruction so that way you can participate in this panel that's about to happen. Sir?
QR code. There's going to be like 5 questions, I think, maybe 4, just about your experiences and things, and it would be great to get your feedback as we kind of step into the panel. Otherwise it'll be really boring. It'll just be my response, sample size of 1. So if you could scan that, it'll take you to the Slido app, and you'll be presented with some questions as we go through here at the beginning of the panel. Thanks.
Okay, while you are doing that, today I want to introduce the moderator for this panel, which we're going to call Data and AI's Role in War, Data Challenges in Logistics, and Supply Chain Planning. Today we have Dr. Harry Dreany. Dr. Harry Dreany is a scientist and researcher at the Naval Surface Warfare Center, Dahlgren Division, focusing on cognitive architecture development. He supports the Marine Corps' Warfighting Lab as the AI development lead in the Science and Technology Division. Dr. Dreany enlisted in the Marine Corps in 1992 and served in the reserves as a capabilities analyst for ONR. He holds a PhD in systems engineering from George Washington University and numerous deployments in civil service roles in his career. Please give it up for Dr. Dreany.
Brandon, thank you. It always sounds cooler to hear that about your life. My kids do not clap when they hear me introduced to anybody, so I do appreciate that. So a little different spin for this afternoon's panel. Obviously, logistics is still the focus, but we're gonna tie some things into it with regards to data and artificial intelligence and the application of that arena into this hard problem of logistics. So I just want to say I have some prepared statement here. So in today's rapid evolving landscape, harnessing the power of AI and data analytics is paramount for operational efficiency and global expeditionary logistics, and the resultant overall effective decision-making. McWill, where I work and support, is exploring how AI specifically and other data-driven technologies will transform the logistics processing, enhance supply chain resilience, and optimize resource allocation across the various domains. We at McWill will look at the role of data and data quality, data storage and access, and the importance of getting it right, and how that plays the ability to leverage artificial intelligence, and how the use of that artificial intelligence will enhance our warfighter. The word enhance is a very, very specific, right? So I want to touch on one of the things that can be a misnomer with regards to artificial intelligence is that we're not looking to replace anybody's job. We're not looking to downsize anybody's command. We're simply looking to enhance or augment what we like to say at McWill, the already well-trained, efficient Marine in their job. So when you look at how we're going to do this, it's not a manpower issue in the sense of numbers. One key discussion point that I want to bring up before I turn over to the panelists so they can introduce themselves is something that, in particularly, that I think about every day as an AI guy in the Marine Corps, especially with logistics. So logistics we look at as a science, right? So I'm a scientist. I have a PhD in systems engineering, and being able to understand the scientific method was a very, very key thing to accomplish that task. So when we look at logistics, we look at it as a science, right? But war is an art. So how do we apply a science to an art in the sense of actually becoming successful in accomplishing our mission? And artificial intelligence, we believe, is a way to do that. And so hopefully we'll get into some of that here in the panel, as well as many other things. Hopefully you guys will find everything that we talk about extremely worthwhile. So what we're going to do now is I'll turn to my left and have the panelists introduce themselves one by one. They'll take a few minutes to tell you about their background and then also what their AI topic du jour is, right? Specifically when it comes to logistics and how they think AI should be applied to this hard problem.
Thanks, Harry. I'm Dr. Jack Long, the Office of Naval Research. I'm actually a Marine reservist, got called back on active duty about a year ago when the Chief AI Officer of the Navy retired. I'd been the deputy I'm a reservist. My background, my PhD is from before the Marine Corps, so I did it in essentially condensed matter physics and nanoengineering, then joined the Marines, 8 years on active duty, got out. I'd been a reservist for a while at Mar 4 Com, and then checked into ONR in 2020, where I took over as a deputy chief officer of the Navy. When I think about AI as a solution or as a capability that can solve tasks, and I think about logistics, it's all about, for me, much of it is around decision support tools, right? When we're looking at these logistics networks, we're looking at what's going on, whether it's very tactical about how to take the maintenance data off of a vehicle or a bird or a helicopter or aircraft, something like that, and be able to make a prediction around that data, or look at a supply chain, or look at where my supply nodes and stockage levels are. All of this is data. And this data is typically too much for a human to do. So we used to be able to do it on spreadsheets, and there's only so much analysis you can do with a spreadsheet. As we have more powerful math and more powerful algorithms, we can get deeper insights. And those insights often, if we can do that, allow us to do decision support, COA analysis, and various ways of looking at that allow the commander to make different decisions. So that's where the art comes in. The science informs the art, where I have 4 different COAs that I can now have an AI help me develop, and then I have to make that final decision. So when I think about that in logistics, in particular when it comes to contested logistics, it's how can I use AI to help me make those better decisions about what I need to do with logistics for my force?
Great, thanks. Good afternoon, everybody. I'm Justin Wolf. I'm the Chief Technology Officer at Systicon. Big thanks for putting on this panel here to everyone that's been involved, both here at the university and with the Marine Corps Logistics Group. So, you know, when we kind of look at the poll, there were about 10% of you have never been burned by logistics. So congratulations on that. Yeah. That might have been the 10% from the last panel that weren't previously in the military, from the general's comment, but hard to say. Anyway, but when we look at the word bubble, you know, there were a few things that kind of came to mind, you know, and of course near and dear to my heart, you know, the one that was kind of most prominent for a while was complicated, right? As we think about the constructs of AI or predictive, you know, analytics in general, and slowly that became surpassed by the idea of efficiency, speed, accuracy. Of course, Skynet was in there, which is also an interesting sort of philosophical conversation we don't necessarily need to get into today. But, you know, things that I really think about here are, how do we make this construct less complicated and more accessible to the average Marine or soldier or airman, that, you know, so they can utilize these tools, right? The idea of, you know, AI works in a lab or works for Chase credit cards that is processing billions of transactions a day, right, is very interesting. But we're in a completely different world where we have a low density number of systems. We're generating gigabytes of sensor data to inform, you know, predictive maintenance algorithms, as an example, which is really not that much, right? And so we're being asked to apply perhaps commercial best practices in a situation where we don't have nearly the data density. And frankly, the kinds of operational scenarios and things that are very, very different. Like, they're very different, right? A peacetime operating scenario is very different from a wartime scenario. So trying to apply some of these things in a very automated way is, I think, outside of the purview today of what a lot of the algorithms and things are capable of. So when we think about AI, a lot of people jump straight to, we're going to push a button and we're going to have everything just work magic. Magic was definitely one of the words that was quite popular up there. So, you know, this idea that we need to augment the maintainer, augment the ops research analyst, is, I think, where, you know, my focus has been. trying to find ways to make their jobs easier and give them more time to do complex analytics rather than massaging a 40-tab spreadsheet into something that's usable for that purpose, right? So that's the way I kind of am thinking about the problem as it is today. Thanks.
Thanks, Justin.
My name's Pat Sullivan. I'm a highly qualified expert serving Army Material Command in Huntsville, Alabama. And first, I don't want, highly qualified and expert. I told my family that, just like other people. My kids laughed uncontrollably for some period of time. I'm a term executive. That's all it means. And I'll leave the government service in about 6 to 8 months. But in this role for Army Material Command, first and foremost, 165,000 soldiers, civilians, and contractors supporting the entirety across the entire globe for sustainment level logistics. We manage the supply chain for all the Army and most of DOD. We also oversee 23 industrial sites. And what my commanding general likes to say is, we're in charge of predictive logistics at the operational and strategic level to influence precision sustainment at the tactical edge. So that's what we're really trying to achieve, is precision sustainment, knowing what we need, where we need it, when we need it, to provide what effect for that commander. So in this role, I advise 2 people inside of AMC. Number 1 is the AMC G3, who's right now Mr. Miles Miyamasu. And number 2 is our Chief Data and Analytics Officer, Dr. Chris Hill. So those 2 coming together, we live in a world where we're trying to advance and test what it is the realm of the possible. We do that in operational context. We learn more when we have use cases that we can drive toward. Our most recent use case is in Ukraine. And AMC has been on that mission since March of 22. We didn't start when the first rounds were fired, but we were in there within a month supporting 18th Airborne Corps, Lieutenant General Chris Donahue, who came to my commanding general and said, look, I'm tired of having to pull these multiple cops. When you guys can tell me about how my intel is influencing my operations, the logistics response, and how we're helping build force readiness for our partners, then let's have a talk. So we immediately moved out to help him by putting people right next to him, both analysts and mostly data scientists. We have a big challenge with data engineers right now, but the data scientists can serve in that role. Our ORSAs can serve in that role in the interim, but data engineering is going to come to the next big need across DOD. We sat right there next to them, developing these capabilities out of need, not out of theory, out of need and practice right there at the edge. And that's how we've applied what we're going to do in the future. Not only we've stopped using AI as a term, we call it advanced analytics because it's AI and ML. And ML, we've been executing ML for decades. And so when we can find the best fit for the problem that we're trying to solve, we're applying advanced analytics to work through that problem on the logistics side. And so I'm happy to talk about anything that we're doing there and how we're applying it for our programs across the entirety of our command as well. And I'm really honored to be here today. So thank you all very much.
George?
Hello, everybody. My name is George Forbes. I'm with the Air Force. So some of you had questions about the Air Force. I can probably answer most of them. I'm in operations, so I'm not in logistics. I'm in the A3 at the Pentagon. My job is to be the Chief Data Officer and the Chief Information Officer for the 3. I did come from the logistics background, though, in the Air Force. I was actually an engineer. I spent 10 years there. My actual undergrad is in civil engineering, but all my graduate work, and I went to a school nearby here in Virginia, at Virginia Tech. Then all my graduate work is in artificial intelligence, machine learning, computer science from Harvard. I still teach there, big data and application development in the cloud, so I still do those kinds of things. Principally, I am in the position to advise our operations community on information necessary to make decisions. I don't make decisions. In fact, I don't even care what the decisions are, but it's my job to give them the information to make the best ones they can as rapidly as possible. Those include principally the ones related to how we resource, train, and equip the Air Force so that we can give our forces to the combatant commanders. My side hustle is I'm the executive sponsor for the Air Force for one of the 6 in the big 6 bundle of data platforms that we have. It's called Envision. So some of my Air Force friends in here might be familiar with that. Some of you might be familiar with the company that provides it. It's called Palantir. So that's my role. I manage a whole portfolio for the Air Force across the entire enterprise. Couple of three things that are important to know in my role as a CIO. We build many apps, mostly disposable, mostly intended to be ones that we can use and dispose of because it moves so rapidly. We use a low-code, no-code solution set. On the other hand, we principally do all of our analytics in Envision. Again, another low-code, no-code solution situation. And I know someone asked about mandating use. I'll talk about that a little bit later, as well as some of the apps we've built for you. And also, I'd like to invite the United States Marine Corps, particularly aviation career fields, to work with us to use our apps. There's no reason. Somebody mentioned, why aren't we using them? We spend a lot of money, time, and effort to manage our 18,853 aviators. Can't imagine we can't add a few more to it to make it easier for you and less expensive. Because at the end of the day, I think the General was talking about a joint environment. I think we are migrating to use the same weapon system here shortly with the F-35, so it doesn't make a lot of sense to do a lot of things differently. So thanks.
Hey, thanks everybody. So one of the common themes I gathered from everybody's short little talks was there's a lot of desire for artificial intelligence using the data to help with decision support. I was at the office, there was a logistician I was talking to, and he mentioned that, and these numbers might be wrong, but you'll get the point. Like, there's like 55 logistics systems in the Marine Corps, and when a young Marine captain is asked to go find some information, he or she will log into maybe 3 of them, right? Because I'll find the answer with the 3 that I'm familiar with. So then you ask the captain next to them, and they're logging into 3 different ones to get the same information. And so their answer is slightly different. And then the next captain uses 3 different systems, so you kind of get the point. So in those 55 systems, whatever that number is, the answer lies in there somewhere, right? So how do we find that answer, and how can maybe artificial intelligence help, right? So if the answer's out there in that 55 systems, is there a tool for artificial intelligence to aggregate that data, find the most correct answer for whatever the task or question that it's looking for? So I'm gonna turn that over and start with Justin to have him sort of jump into that discussion piece about how we can create these efficiencies for decision-making using artificial intelligence.
Yeah. It's a great question. I mean, I think sort of fundamentally, there's a step that will make implementation of AI more efficient, and that is sunsetting 48 of those 55, right? I mean, seriously, like, as within NAVC and NAVAIR as well, under the Model-Based Product Support Initiative, which is a program record that sought to sunset many of those legacy systems, what they realized was that there was, in fact, a lot of duplication. And when we build readiness models today of various air and sea platforms, there are 14 different legacy systems that contain more or less the same information. So how do you make sense of that? Well, you could apply some very interesting heuristics and start to look at the differences between those tools and develop some very elegant AI and ML and just raw data analytics solutions to parse those. Or you could say one of those will be the one, and we shall all use those and move on. And so I think, and in the meantime, right, there's other things that we could really do to understand, in our MRO tools, right, we have a lot of free text fields. So, you could apply some language models to those to be able to understand that, yes, we entered into the system, that we performed maintenance on the platform, but that's not helpful in understanding what LRU was actually removed and replaced, right? So instead of parsing all the supply records, trying to find order that was around the same time, and there's some things you could do to parse those things. But at its core, I think we often jump to AI as is going to fix everything in the department. And the answer is no, some of our core fundamental data systems with some re-architecting could be not only much better and easier to use, but then also then enable AI to be put on top of this. So I think step one is understanding that AI is not a magic bullet. Machine learning is not a magic bullet. There's a lot of things that we can do with them, but but we also need to think about how we're using our systems, how we're training our sailors, soldiers, Marines, and airmen to use those systems, and what our real goal is, right? We can't just say, sprinkle some AI on it and it's gonna get much better, right? We've got to think about what is the core fundamental issue that we're trying to address and find ways to do that without spending huge amounts of money, right? Or architect solutions that aren't necessary.
So I'm going to turn it over, or push it over to you, Pat. Can you talk about some primary challenges of integrating AI into these existing systems and maybe creating some sort of tool that can, if not sunset those 48 systems, pull together maybe some sort of, conduit for those systems to come to?
And so for the Marine Corps, I'll give you scale real quickly because we're going through this right now across the Army. Add a 0 to what you have, that's what the Army's dealing with is in relation to defense business systems. We have nearly 500 defense business systems that are active in our portfolio management system today. We are working feverishly to try to bring them down. And for those of you who don't know, the Army is on a path to converge 5 ERPs into a single ERP. Your cards and letters of sympathy would be greatly appreciated all throughout this process. It's phenomenal what what it's taking to execute that right now, and we've not even deployed anything yet. So as we think about this, it always starts with the data. And where we struggle is where that data comes from and what the provenance of it is, and then how we treat it once we get it into this unified, integrated capability, right? This system. Is it labeled? Is it tagged? Do we have the right people overseeing that environment, understanding what the boundaries of that data environment are, and then giving us the capabilities we need on top of it? I have all the faith in the world in our Army data scientists and ORSs who write the code, whether it's Python or whatever other script they're using. When they start getting the data they need, the analytics come. And we're seeing that right now. We're seeing it at a grassroots level. And we're seeing that we can put communities of interest together, and we still do call them interest. Everybody likes to say, well, you should call it this. It's a community of interest is what we call it. When we pull those folks together, they're accomplishing amazing things as it relates to the analytics. It's the data piece that we've not quite gotten figured out that we need to continually address to sort out how we can do what Justin's saying. Let's bring it together at the top. Let's figure out all these other generating systems and seeing how many places we're generating that data. And then let's start deprecating ourselves and sunsetting some of these systems that aren't providing us value. Redundancy is good, replication is bad, and it puts us at higher risk.
Thanks, I appreciate that. So we're gonna veer off a little bit and sort of change the topic just a little bit. However, it's still gonna be specific to artificial intelligence and helping with making decisions. I'm gonna ask Jack to chime in on this. How do you see AI enhancing our decision-making at the strategic level in logistics to ensure alignment with our broader military objectives?
Thanks. I think when I actually look at AI for the decision-making, I think that's where we're going to see most of the impact in the coming years. When you look at the autonomy stack, right, people want their autonomous killer robot. Obviously, usually where that starts down there is a very human-in-the-loop tool. And as we start to trust it, we take the human out of the loop. So for example, the very first types of AI in your car was a lane keeping system that just notified you if you're out of your lane. Over time, we learned to trust the decision it made when the notification was proper, and then automated the ability to put it back in the lane. So when you think about AI, it starts as a decision support tool we call human in the loop, and eventually we take it human out of the loop. When I think about the strategic level of war, that's still going to be a human-in-the-loop decision for a very, very, very long time. And that's having tools that help us think through the problem at the level you're dealing with. Whether that's an AI that can help you play chess, AI that can help you play Go, to help you with the scenario analysis you're working on. And we're seeing the expansion of these decision support tools. It went from chess to Go to StarCraft. And each of these was a more complex scenario in which it had to operate. And it got into poker, single player, or one-on-one poker, and now like full poker of 10 players. We've got AI tools that can beat humans at that. But when you pair them with a human, it's still the best in the world. So when I think about that, when I start to see this, thinking about this, that's where I see AI helping people think through scenarios, generate COAs, and then assess COAs to help through, with the human still having the creativity that comes with it, just like a human in an AI chess playing program still beats any AI chess playing program out there we've come up with so far. So when I think that through, that's where I see it, and I see this at every single level. One of the premier AI products from the Marine Corps was developed by a captain at NPS, Ryan Helm, called ARES, Automated Reconnaissance and Estimate of the Situation. It was a decision support tool that initially helped him identify a landing zone for a helo insert for his day job as an infantry officer. We then expanded it, and it was used computer vision to identify where a good spot would be, used AI to overlay where the objective was, where enemy positions were, and create a COA analysis tool to help an infantry officer do that. We put it on the Boxer ARG on the 15th MEU, tested it. They're like, for R2P2, this is better for making MCUs than anything we've got. That's where AI really is. And it's a simple tool, and you can do that for that particular use case, or you can start to add on additional use cases for different types of planning scenarios.
Thanks, Jack. So, George, I'm going to throw this question at you. When Justin first was looking at the Slido, and he kind of challenged the data that was being presented, so that made me think about, okay, the quality of the data that we have. And so, George, let me know why is data quality crucial for the success of AI-driven logistics solutions, especially with the military operations?
That's a great question. Thank you very much. In fact, I was thinking of that as the first three questions.
We were in sync, brother. Yep.
Were asked, because we jumped right into AI, and I think that the predecessor event for all AI is data, right? That's the fuel that runs all of this. Without it, AI doesn't really work. In fact, with poor data, AI works probably to your detriment more than your reward, if you will. So I think not only is data quality important, it's vital, right? So it's funny, my daughter was asking me about it just this weekend. I'm a data scientist. She's a political scientist. You can see how this doesn't go so well. And I told her, I said, how much gas do you put into your car that has leaves and stems and dirt in it? And the answer is, of course, none, because that would just destroy her engine. Well, it's really no different here, right? So the more junk you put into your AI machines, the more difficult and problematic you're going to have. So that's the analogy I gave my political science daughter. Maybe it applies to Marines. And by the way, there's
a lot of political science
because
majors
my daughter's
out there.
brilliant, by the way, just making sure we understand that connotation there. But clearly that's important. So then someone asked me over lunch about how do you do the data quality thing. There's a couple of ways. I look at data quality in three ways to make it better. One is you can first start by what the general was talking about, change your mind. You're never going to have good quality data, ever. Don't ever expect it. Don't ever look for it. Don't ever get irritated because you don't have it. It'll never happen. I'm a data scientist. I've yet to see good data show up, number one. Number two, there's ways for you to get the data that you want right properly up front, and that's influencing the applications that you use to collect the data. I like to say that I make applications to feed my data habit. That's precisely why. Because I want to influence how the data is collected so that I can get good data to begin with. And then the third thing is, barring those two other things that are not possible to change, is to look at your data and use tools to correct it. All right, so every data set that you have, you can run it through a machine to tell you how high the quality is or how low the quality is. But we also know that you can use context clues. You can use a number of other techniques that permit you to clean that data without ever having to talk to anybody. So as an example, we have a system that we use to determine how ready our forces are. You use the same one. It's DERS. And it has trouble. The thing about it is that we want to know how much trouble. We had 138,000 errors in our system, and we had 2 correct fields. 2 correct fields from, anyone guess? That's right, the chaplains. So our chaplains had the 2 correct fields. Everyone else had it wrong. So does that mean the whole system's wrong? that means a whole lot of things are wrong. But more importantly, we don't have time to go and fix 138,000 errors. But what we do have time to do is go and put business rules against them, right? So we can now use AI to business rule against that dirty data set to make it cleaner. And the good news is, none of you in here have to worry about it because your AI scientists and data folks will get you healthier. And that what brings up the complicated piece in efficiency. Everyone in here, I like to say generally, I work in the Pentagon. And just last week we had a newcomers orientation, and I told everyone in the audience there that from now on their weapon system is data. And the reason that's true is because none of them are ever going to operate a weapon system. They're all going to operate a computer or a desk or maybe a phone. But the important thing is all of them are going to be AI adjacent. So they have to be smart about it. I'm not asking them to be as smart as I am about how to clean up that data, but understand the limitations and capability and know where to go to get help and where to use it. Because what we try to do is move everybody from manual tasks to cognitive tasks, and AI helps us do that. So if I don't have to spend 6 weeks doing a spreadsheet to get to an answer, but I can do it in 3 clicks, I just liberated myself from hours and weeks of toil and permitted myself to have much more cognitive space to begin analyzing the results that I'm getting. So that's where we see AI coming together. And that's how data quality is important to making sure those things are there to enable us to have good quality information. Does that answer the question?
I think you did a great job, George. But I'm going to throw you a curveball. The Marine Corps, so an individual Marine might look at our data sources and say, man, we have a lot of data. But if you step back and you look, we actually don't have a lot of data in comparison to, per capita, per piece of gear, per Marine. Our data sources are significantly smaller than what you might imagine. And so I'm going to turn it over to Jack to talk a little bit about why data maybe is not that important.
I would say, yeah, I think it very much depends on the kind of AI. When you look at certain kind of statistical focused AI, data is absolutely critical. So when I think about predictive maintenance, I think about it's mathematically very similar to predicting the weather, right? So weather, our weather models are just a form of AI. We take in a mass amount of data from all those weather stations, and we're able to make predictions an hour, a day, a week into the future. We want to do the same thing with predictive analytics on those vehicles and those aircraft, right? Take in all this data. You need to have the right data, and you need to build a model that is actually accurate, and that usually takes time. So when we look at a lot of this predictive analytics, it does take the data, and the data absolutely has to be clean and accurate. Otherwise, what you're modeling, you're getting garbage in, garbage out. When I look at certain other kinds of AI, what we find is like on some of the more modern AI now, the AI is bringing the data with it. So for example, AlphaGo was an AI trained on a bunch of human games of Go and ended up getting better than humans. AlphaGo 0 beat AlphaGo 1,000 to 1. Was that much better? And the amount of data it was trained on is in the name of it, 0. It created its own data, right? So you didn't actually need to feed it any data to do it. It was what's called reinforcement learning playing itself. Similarly with Libratus, the poker playing AI was actually trained by playing itself. So you didn't need to ingest a huge amount of data. You needed to define the rules of what it was doing. When we look at a lot of this generative AI and LLMs, it's in the name, right? Generative pre-trained transformer. The pre-trained piece means the data is built into the training of the model. The model comes with all the data in it. So when we deploy some of these more modern AIs to help us with these decision support tools and to do things, they don't necessarily need as much data as the old ones, but those are for very particular use cases. So we have to focus on what data are we going to need for what. Much of our predictive and much of our modeling is going to require us to have a data ops infrastructure, and the SDO is running out the integrated mission data fabric, basically so you can touch all the data anywhere at any time you need to. But also some of the modern AI we're rolling out brings its own data essentially. It's trained into the algorithm, so you don't need to necessarily be running it on data. It's all about how we employ AI, and there's different kinds of AI that are going to have different use cases.
Yeah, thanks. So I'll jump in real quick. So when we think about operating on the tactical edge, the cloud or the network or whatever you call it that we're using, it's what's the old saying? If I'm out there, I'm being targeted. So it's sort of the same thing with your data or with your information. It's going to be targeted, especially at that tactical edge. And so we know that we're going to be compromised at some point. So then what's the next step, right? Do we have redundant systems? Do we just shut down that cloud and immediately establish a new one? Is all that data lost, right? It's going to be a very, very challenging environment with regards to that. So the ability to create synthetic data or the ability to model with sparse data becomes critical at the tactical edge. So I challenge, one of the things I'll say is I challenge all of us that are in this space to think about that, right? When instead of trying to find a way to manage these large amounts of data in an arena that it's probably going to be targeted, let's figure out how to use smaller amounts of data and still be successful in doing that. So that brings me to, hey, Pat, I'd like you to touch on, as we talk about like the future technology, right? And how the military can use the future of AI-driven technology to reach mission accomplishment.
Yeah, so I think it starts with decision support, and we've talked about that a number of times. We have to do a better job at, as Jack said, we talk about data mesh, and we talk about computational governance inside of that data mesh. We're not there in the Army. Maybe the Marine Corps is a long way ahead of us, right? But we're having troubles right now as it relates to interoperability, trading data with DLA. That's the Army, and DLA, not just doing pushes of data from one to the other, having the ability to go in, discover that data, and pull it out. And some people say, well, Havana, that's where it's all at. We found that to be problematic as well. We have to overcome the governance and the constrictions that we have right now. We have to do it in the right way, but the centralized governance is going to constrain commanders at the tactical edge. Commanders at the tactical edge have to have at echelon the ability to make decisions. They have to be able to source the data they need and execute it inside of that box. And so there are great COTS platforms. We were just talking about COTS a while ago and how that there are capabilities out there right now that can enable us. Just like the Air Force, AMC specifically is a Palantir shop. We have our own data platform where we're creating decision support for commanders in the field right now at echelon. That control and those requirements to understand who's making what decisions for what effect at echelon is going to be critical to how we deliver end-to-end logistics to achieve what we talk about as it relates to precision sustainment and making sure that soldiers, sailors, airmen, and Marines have what they need at the right time to affect the battle. We have to understand the intelligence and operational pieces of it as well. We're doing those integrations, and that is straight up an AI application to make sure that we're layering it appropriately and just pulling the data elements that we need to create the right picture for that commander. And so as we continue to figure out what are the questions that need to be answered at echelon, what are the sources of the data, how do we source that data and bring it in appropriately, it's going to help. We can do a lot of learning, and we've been doing this. We'll create a curated set, and we're not as far maybe as the Marines are on creating synthetic sets to actually help us drive toward what an answer might be. But what we're doing is creating curated sets that can help drive us and leverage an LLM or some other type of deep learning model that can discover novel options and approaches to addressing that problem set. And so everything's use case driven. Figure out what the scenario is, figure out what your use case is. Now let's sort out what the best way and the best method and technique is to answer that specific problem.
Thanks. So Justin, I'm going to push it over to you and ask you about how AI can help optimize resource allocation. Obviously, the Marine Corps, right? At boot camp and OCS, one of the first things they teach is one shot, one kill. I used to think that was because we're badass, but it was more because I don't have enough bullets, right? Yeah. So I don't have enough rounds, so you better get it right. Help us understand AI, optimization, resource allocation.
Yeah, this is great. I mean, it's certainly important, right? And of course, the efficiency tag there in the word bubble, certainly really critical. You know, when we think about to the joint program, right, with the Air Force and the Marine Corps and the Navy, and I guess 19 other countries now of F-35. Every year we buy more spare parts. Every year we train more maintainers. Every year we're going to buy more support and test equipment until about 2042-ish, when the program hits about 3,000 aircraft and then slowly declines as NGAD perhaps comes online, right? What does that mean? That means that every year we're going to buy spare parts that are going to be delivered 3 to 4 years beyond that. So we're trying to figure out what are the component reliability for every LRU, every maintenance significant part in that aircraft, and what will that reliability be in, for this year, 2028? And how many flying hours are we going to fly per tail, per country, per, in 2028? And how many maintenance man hours will it take to do that work in 2028? Well, what's going to happen between now and 2028? Who knows, right? But I'll tell you, the planning factors are all wrong, right? Whatever we're using. Israel flew an entire year's worth of flying hours in a month after October 17th, right? So, there's some interesting things that are going to happen that are outside of our control today. What we found is that we're able to, using some AI tools, turn the fracas process, so how we determine what a part's failure rate or MTBF is, right, which is one of the factors we'd use to buy spares. That process took 8 months when we had the OEM doing it manually. When we applied some smart tools and some AI programs and just some good decision analytics, it takes 8 hours, right? So when we get new maintenance history data, we're able to update our failure rates so that we have the latest failure data, not something that's almost a year old. You can apply the same thing to when a customer gives us, and because there's 20 different inputs for what the flying hours would be on that program, not to pick on anybody, but a particular customer has never flown their entire requested flying hour program. They're always
And we never will.
Yeah, so they're only flying maximum about 90% of what they've said they're going to fly. So if we're trying to be more efficient, right, should we buy spares to the 100% or should we buy spares to what we know they're actually going to fly? Well, that's just one data point, but if you apply that across many different customers, there's some good work to be done there in right-sizing things to be more efficient, to be more effective, using some of these tools. Are these things that can be done in a manual way with enough people? Exactly, but that's the whole point of AI, right? It enables you to do and get a lot of that analysis done much, much faster, so the decisions that we're making are as close to reality as possible and as close to what we think reality will be, off into the future. So there's some great examples of applying these things today on programs outside of the sensor data that might exist on the program, right? This is just helping, AI tools helping analysts be better analysts, right? Just like we hopefully all use ChatGPT today. If you write a fitness evaluation without ChatGPT, I think you're probably wrong, right? Because, there's no reason not to, right? Write me just type it in, and it'll give you a template that saves you 20 minutes, right? It's perfect. Just one example.
Yeah, great, thank you. So as we were talking about using AI to help with resource allocation, a couple of things we've talked about, today, even before this panel, is like, well, if we just sort of sprinkle some AI, right? So I can do that at work because that's kind of cool, right? Hey, we'll just put some AI on that and we'll solve the problem. And everybody's like, oh, okay, yeah, sure. Obviously, it's not quite like that. So I want Jack and then George both to touch on this question. It's like, how do we work towards changing the culture within our service to be able to understand how to use artificial intelligence correctly?
No, it's a great question. I think it really starts with understanding. So the earlier question about I got all these different data sources, if you want to sprinkle AI on that, that's actually really easy to do. I can build LLMs, I can build 55 different LLMs that can interrogate those 55 different data sources and have one orchestration model that can basically ask that question. Marine Corps is looking to build something like that right now, so all of our different data sources talk to each other through LLMs. So that's sprinkling AI on something, and you can solve it that way. But like NASA and the proverbial $1 million pen that writes in space, AI isn't necessarily the best solution to a problem. The Russians had a pencil, Marine Corps would have used a crayon if they'd asked us. So just because AI is a solution doesn't mean it's the best one. What we're really talking about with those 55 systems is that's a systems problem, the way we've built them, not an AI problem. Yes, we can solve it with AI, but is that Band-Aid on it? So I think what we really need to do when we start to think about what is an AI, what is a solution that is solvable with AI, and the way I define AI is it's a synthetic device that can solve a task, not a problem, it solves a task, and that's really how to think about AI. Understanding the capability of AI, the algorithms that we can build to do something, the data that we've got and the compute we use to do that, what can that do, and then what is the task I want to solve? Some people ask for tasks that are very complex and very hard to solve with AI. Often where we've seen the biggest success is you break that down to a very specific task, very simple task. I want to recognize an object in an image, right? That's object recognition. Now I want to recognize an object in a video. Then I want to be able to track that object over time. Those are tasks that we can build algorithms to solve that we've got the data for. But that requires people that understand how AI actually works and understands that it's a series of equations and math and it's not some spooky thing, right? One of the reasons if you look at autonomy, in AI, autonomy is not one big brain that runs a system. It's usually a bunch of different pieces of AI all working together. One is object detection, another is object recognition, one is route planning, one is object avoidance. All these are different AIs that are put together to give the illusion of one brain running an autonomous system. In reality, it's a bunch of individual tasks. That basic understanding doesn't exist in our force yet. And I think that when we start to think about using data to make decisions, data analytics. Having a force that knows how to do that is critical. I look at 400 years ago when you were a peasant and most peasants couldn't read, you could float through life fine not knowing how to read, and most people did. You could live a whole life, have kids, go on and do everything without ever having to learn to read. But if you could read, the world was a little different for you. You understood it deeper, and there was a different path open to you. I look at coding very much the same way today, or at least the understanding of how software code and some of these things work. If you don't know how to code, you can have a nice long life, float along and just do your thing. Phones will work for you, all this stuff will work, but if you know how to code, you have a deeper understanding of what goes on. When you go to war with a bunch of tools that work on code, and you don't know how to take them apart and break that code down, now we get ourselves into a pickle. Used to be every sailor in the Navy had to know how to tie knots and rope. Not the case anymore. Ships don't work on wind and sails, but they do run on code. So where's the expectation that just like every Marine is a rifleman, regardless if you end up your job, is there an expectation we all understand data analytics or at least data at a very basic level just to know a little bit? So I think inculcating that into the service, if it's going to be a critical function of how we fight a war, needs to be something that we do.
Thanks, Jack. So in the Marine Corps, there's a lot more political science and history majors than there are STEM majors. Right? I majored in Marine Corps. So the Air Force has a higher percentage of an understanding of how science, technology, engineering, math. So what are you guys doing to change the culture and understanding artificial intelligence that may be different than where we are?
We're letting natural law take its effect. We call it Darwinism. Thank you. For those of you who didn't get it, congratulations, you know what pool you're in. Somebody knows Latin. Okay, so all kidding aside, we use natural law. There's a law. It's called Bass's Law of Diffusion. Has anyone ever heard of it? Some of you up here probably have, right? So Bass's Law of Diffusion, you've seen it in breakthrough technologies like the refrigerator or air conditioning or wireless phones or telecommunications or the internet. Bass's Law of Diffusion talks about how people adopt technology. So somebody asked a question earlier today to the general about mandating a particular system. I don't know what that system was, but it really doesn't matter. Because what we're doing differently is we're not mandating anything. What we're doing instead is using our policy jujitsu to take Bass's Law and put it in practice. In short, what Bass's Law says to do is go find your early adopters. Go find your early adopters and get them fired up. Your early adopters will then bring pioneers and pathfinders along with them to the point that you make critical mass. That's the exact same technique pop stars use. That's the exact same technique Instagram uses. That's the exact same technique YouTube uses. And that's the exact same technique we're using. So policy is cool. But I think when the undersecretary was up here, some of you raised your hand when he asked if you read that national security directive, and then even few of you were more honest when he asked if you read that DOTI. I think both of you are probably left already. But still, okay, all right, at least one of you are here. But the point is, policy doesn't really change the culture. It's looking at social proof. It's using social techniques like that help us get there. And in fact, that's precisely what we did when we used Envision, which is a fundamental piece for us. We went last year from around 4,000 users on a daily basis to around 46,000 this year. We went from around 6,000 applications built inside that domain to around 42,000, 45,000, and growing. And we didn't put a policy memo out at all. What we did was we promoted our early adopters, and we promoted use by some pathfinding units. The next thing we're doing is understanding what it takes to be proficient at a particular technique. I mentioned this term AI adjacent a minute ago. I didn't coin that. There's a company called Workera. You can go find them yourself. Workera is founded by two Stanford professors who do AI, and they found they were building these tools, but no one was using them, although they were really fantastic. They found that the problem was the culture. So they said, hang on, why don't we figure out how to get the culture more apt to adopt these? And we're using their techniques. So that's the second key to our success, if you will, is we're deliberately finding how to get adoption rolling and deliberately finding these people and groups of people who are using it to get to our 42%, which is critical mass. Because once you hit 42%, it pretty much just takes off like, wow, it becomes viral. So for us, it's policy, sure, because we got to put it all down, we got to write it up. But really, the secret sauce for us is using natural law, in particular laws on how people adopt technology, and using that to our advantage and exploiting that, if you will, deliberately. So it's not left simply to chance.
Thanks.
And I was going to say, the Marine Corps just published an AI strategy about a month ago. So it's out there right now, and we're actively looking for some of those early adopters that want to start now, get ahead of it and say, hey, my command's going to stand up an AI cell and start looking at what those potential use cases for AI in my command is. If those, when they stand up, we'll sync them up with both the Service Data Office, DCI, as well as Dawn CDAO and the CDAO from the DoD. So if you've got people that want to be early adopters, we're trying to do the same exact thing of like, cool, not everyone needs to be at the forefront, but those that want to go after it, we'll bring the support for you.
Well, there's one other thing I failed to mention here in my notes. The notion of getting people trained up and familiar in AI adjacent isn't easy. I know that's the case for many of you. So we were fortunate enough to work with some representatives who gave us a congressional insert last year. And so we're going to be working with a university in that particular congressperson's district to create a center of excellence for fluency and literacy for data and AI. The good news is it's brought to us by the United States of America. So I own that program, and I don't see any prohibition why the United States can't have anybody who wants to come and participate in that from the government side anyway. I know there are restrictions otherwise, but so that means our friends here in the Marine Corps, I know we got some Army and as well as some Navy folks here in the room, but if you'd like to participate or know more about it as we roll it out, I'm happy to include you in that.
Thanks, George. So it looks like we've hit our time limit. So I'd like you all to just give a round of applause to the panel and thank them for their time.